Hello guys, I am Santosh Singh and today we are going to see the Apache Hadoop part 3 and in this part we are going to see the HDFS architecture and in the HDFS architecture we will see that how to store data on HDFS and how to process data on HDFS. So first of all we will see that how to store data on HDFS. So let's start the HDFS architecture. So in HDFS architecture, if anyone will ask that what is the HDFS, then you should not say that HDFS means Hadoop Distributed File System. You should say that HDFS means it is a special design file system for storing huge datasets with cluster of commodity hardware and with streaming access pattern. As we discussed these things earlier, that what is the huge datasets, what is the community hardware, and what is the streaming access pattern. So huge datasets means a very large volume of data, very big data. So that is the known as huge datasets. Commodity hardware means cheap hardware. It means it is not very highly hardware. We can use cheap hardware in HDFS, and streaming access pattern means write once and read any number of times. So as we know the Java slogan, I think you all guys must know the slogan of Java. The slogan of Java is Ora. Ora means write once and run anywhere. This is the slogan of Java. It means that program write once and execute on any platform. It means any operating system like Windows, Linux, or any operating system it can be run or execute. So like this way Hadoop also have a slogan. Hadoop have slogan write once and read any number of times. So this slogan write once read any number of times is known as streaming access pattern. So HDFS work on huge data sets with cluster of commodity hardware and with streaming access pattern. So if anyone will ask you what is the HDFS, then you should say this definition. You should not say that HDFS means Hadoop Distributed File System. Hadoop HDFS architecture follow the master slave technology. As we know that Hadoop follow the master slave technology and we'll see. So next things, as we know that hard disk is made of block and sectors, and these are known as the blocks. These area are known as the block and these are known as the sectors. So we also know that in Windows NTFS the block size is 4 KB and in Linux the block size is 4 KB. Here is a questions that suppose that I have a 2 KB of file, and if I store 2 KB of file in a block in window, so remaining 2 KB will use for any other file or it will not use. I am repeating the question again. Suppose that I am storing the 2 KB of file in 4 KB of block size. So, sorry, input size is 2 KB in that block. So, in future, we can use that 2 KB or we cannot use that 2 KB. So, I think you all guys are thinking that it might be used or it might be not used, but the answer is the remaining 2 KB cannot be used in case of Windows or in case of Linux if we are going to store any 2 KB of file. So like this way, if the block size in window is 4 KB, the block size in Hadoop, as we know that is the 128 MB or more than that, we can configure any number based on the HDFS site.xml file. So let's move further that how to store data on HDFS. So HDFS is given for 3 replication by default for storing on DataNode. If any data node will be destroyed, then data can be recovered by another data copy. So guys, we know that HDFS follow the replication policy and it store the 3 replication by default. First is it store the main copy and 2 its replica. We know that in HDFS, as we know that HDFS follow the replication policy and by default it follow the 3 replication policy. First it store the main copy and 2 its replica. If data node fail or crash, then we can get the same copy from its replica. So as we know that DataNode is used for storing actual data. So guys, as we know that on HDFS, DataNode, NameNode and secondary NameNode are used for storing purpose. So DataNode use the actual data, whereas NameNode is used for storing metadata. We will see that what is the metadata. Metadata means we will see after a few minutes. So if NameNode will not accessible, then we cannot access the metadata. Yes. Why? Because metadata store on NameNode. So let's see the next things which is very important. I am trying to elaborate that how to store data on HDFS by this picture. So this is the very important things, and by seeing this image you can assume that this is very complicated, but if you focus here, if you concentrate here, then it is very easy things. So we will see that how HDFS store the data on DataNode. So guys, as we know that for storing the actual data we use the DataNode. So here we can see the DataNode 1, DataNode 2, DataNode 3, DataNode 4 and so on, DataNode 12. And on DataNode we can also see the task tracker. We will see the task tracker in my next session, that what task tracker do and why it is used. Task tracker is used in processing. So today we are going to see that how HDFS store the data, and in next session we will see that how HDFS process the data. So suppose that there is a 450 MB file and file name is abcd.txt, and a client want to store this file onto the HDFS. So for storing on HDFS, he should or she should store data on DataNode, because DataNode store the actual data. So guys, clients should, first of all, clients should communicate to NameNode, because he do not know that how and where I store the data into DataNode. So first he communicate with NameNode. So as we are seeing here, client try to communicate with NameNode. Client contact with NameNode, and when he contact with NameNode and asked that hey NameNode, I would like to store this abcd.txt file on the HDFS, then please let me know where should I store. So NameNode, as we know that NameNode is a master service and it communicates with slave service, that is DataNode. DataNode and NameNode can communicate to each other, and every DataNode send block report and heartbeat to NameNode in a short period of time. Every DataNode send a heartbeat to NameNode and say that hey NameNode, I am still live and ready to work. And after a period of time, it send the block report also to NameNode that hey NameNode, in my data node these and these blocks are free and I am ready to store data on my data node or in my block. So NameNode has the all information of these data nodes, that how many blocks are empty and how many blocks are full. So NameNode have the all information about data node. So when client communicate to NameNode that hey NameNode, I would like to store this file on HDFS. So at that time NameNode reply that hey client, this it means 1358. This hey client, this data node have the empty blocks. You can store your data on these data nodes. So when NameNode reply that data node 1358 have the empty blocks, you can store this data onto the data node. So when this file is going to store on data node, then what happen? First, Hadoop break this big file into input split, that is known as chunks. Hadoop break this file into number of input splits. And how many number of input splits Hadoop break? As we know that number of input split is equal to size of file upon block size. So as we are assuming that here is 128 MB block size, so 450 upon 128 is equal to 3 block size have the 128 MB of data and 1 block size will have the 66 MB of data. So when we are going to split 450 MB file, then it will break into 4 input split. So whenever we are going to store a data onto the HDFS, it will break that big file into number of input splits. So I be clear about these things, that when we are going to store a data, a big file, then that big file break split into input split. How many number of input split will Hadoop break? Hadoop break into the size of file upon the size of block. Those many number of input split Hadoop break. So suppose that the file abcd.txt break into 4 input split like a.txt, which have the size 128 MB, b.txt have size 128 MB, c.txt has size 128 MB, and d.txt has size 66 MB. So when client know that these data node have empty blocks, then it will go and store these file into these data nodes. So first of all, suppose that we are going to store a.txt on data node 1, because data node 1 have the empty block. So when client will store a.txt on data node 1, then it will store a.txt on data node 1 and it will send a acknowledgement to the client that hey client, I store a.txt on data node 1, and after storing the data node 1, Hadoop follow the replication policy, so data node 1 again replicate this file to data node 2 and data node 4. It can replicate on any other data node where is the empty blocks. There it can be put the replication, or it can put the replicated file. So suppose that if data node 2 have the empty blocks and if data node 4 have the empty block, then data node 1 put the a.txt file into data node 2 and second replicated copy put the data node 4. Like same way, b.txt file put on data node 3 and a 2 replicated copy will put on data node 7 and data node 8. It can be put on any other data node where block is empty. So as we can see that c.txt and d.txt, it can also put on data node c.txt input split can put on data node 5 and its first replication can be put on data node 6 and second replication can be put on data node 12. And like d.txt, we can put it on data node 8, as we are seeing this notation, this arrow, that d.txt we are putting the data node 8 and its first replication we are putting the data node 9 and its second replication we are putting the data node 11. When we are replicating d.txt file on data node 9, so after successful storing this file on data node 9, data node 9 again send a acknowledgement to data node 8 that hey data node 8, I successfully store this file onto my block. Like this way, when we are storing the second replication copy on data node 11, that after storing the replicated copy on data node 11, it send a acknowledgement to data and said that hey data node, I store the second replication copy on data node 11 successfully. So like this way we store this input split into these data nodes. So guys, client store their file into these data nodes. Now NameNode have each information about these data nodes. That every data node send block report and heartbeat to NameNode in every short period of time. So after storing these input split to these data nodes, that each data nodes send a block report to NameNode, as we are seeing this arrow, that these data nodes send a block report, these data nodes send a block report, these send block report. It means each data node send a block report to NameNode and say that hey NameNode, these are the my blocks reports that which block had the which file. So NameNode have the all metadata information about blocks of data nodes. So guys, as we know that master service NameNode and slave service DataNode communicate to each other, and DataNode send each block report to NameNode after a after a short time, it might be 10 seconds. So guys, as we know that NameNode is a master service and DataNode is a slave service, and NameNode and DataNode communicate to each other, and DataNode send each block report to the NameNode. In every 10 seconds, DataNode send block report to the NameNode. So here we can see that metadata means data about data. So after storing these input split, DataNode send all information to NameNode, and what those information DataNode send to the NameNode. DataNode send to the NameNode that hey NameNode, a.txt file has been stored on one DataNode, two DataNode, and four DataNode. 1, 2, and 4 DataNode. And b.txt file stored on 3, 7, and 8 DataNode. c.txt file stored on 5, 6, and 12 DataNode. d.txt file stored on 8, 9, and 11 DataNodes. So like this way, NameNode have the information about file abcd.txt that where this file input split has been stored on which data node. And guys, NameNode also have the information about each blocks. So it also have information that a.txt file store on which block on data node 1, and which block on data node 2, and which block on data node 4. Then this information also NameNode have that on which block and in which data node this file is stored. So NameNode have the complete metadata information about the file. So like this way, the client can store their data onto DataNode. When client come for processing, then he again contact to NameNode that hey NameNode, this is the file abcd.txt I store on the HDFS. Now I need this file. So again he contact to NameNode. So NameNode have the information that where abcd.txt file is stored and in which block this file. Guys, like this way we store the data onto HDFS. As we can see here that these are the replica copy. I try to point replica here that 2, 4, 7, 8, 6, 12, 9, 11. These are the replica copy. So guys, as we see that the all metadata information stored by NameNode. It means NameNode have the metadata information that where and in which block this file is stored. Suppose if NameNode fail, then we cannot access this file from these data nodes because no one know that which data node have the which file in which block. Only name node know these all information about file. For name node we use very high configuration and high reliable hardware. For name node we do not use the cheap hardware. For data node we use the cheap hardware, but for name node we use the high reliable hardware, because if name node failed, then we cannot access any data from HDFS. That is also known as single point of failure. So guys, be clear that for name node we always use the high reliable configure system and hard drive. DataNode is nothing. DataNode is a machine with hard drive. Suppose that this DataNode have 500 GB of hard disk, and this DataNode also have 500 GB of hard disk. This might be have 1 TB of hard disk, and so on. So these are the system which have hard disk for storing purpose. So guys, like this way I am trying to elaborate that how client store data on HDFS. If you have any questions, then you can ask. I will try to answer those questions. So let's see next things, that what will happen if the metadata is going to lost, then entire cluster will not accessible. As we know that if metadata will lost, if name node will lost, then we cannot access the entire cluster, we cannot access the entire HDFS, because all information about entire cluster have the name node. So to overcome of loss of metadata, we use high reliable hardware for name node. As we discussed that for name node we always use high reliable hardware for name node. You might thinking that I am using a laptop of 1 lakh, 1.5 lakh, 2 lakhs, then how we can say that it is not high reliable hardware. But guys, the hard disk we are using in laptop, that is cheap hard disk, that is known as community hardware, because that hard disk might be 40k or 50,000 rupees, but when we are going to purchase a high reliable hard disk in market of 1 TB, then it might be 10 lakh or more than 10 lakh. So guys, like this way, if we are using laptop of 50,000, 1 lakh, then that is not high reliable hardware laptop. That if name node is going to loss, then nothing will possible, then it is called the single point of failure. So this question also asked in interview, that what is the single point of failure. So guys, be clear that single point of failure means if name node lost, then we can lose everything. So guys, like this way I am trying to elaborate store data on HDFS in HDFS architecture. We will see next things, that how to process data on HDFS in next session. So if you have any query or any questions or any suggestions, then you can comment me. I will try to. So guys, thanks for watching.